Hello everyone, my name is Han Xiang. This is question 1 of homework 3 in the course Probability and Stochastic Process course. And in these questions, the probability of x equals to k is equals to b times k times p to the power of k minus 1. And in this function, k is equals to 1 to 3 to infinite. And the p is bigger than 0 and smaller than 1. At first, we want to find the b, and so that the probability function is a mass function. So at first, we could find in the function this part is equals to the derivative of p to the p to the power of k. So we could transform the function to the p x equals to k is b times derivative of p. And we want to test this is the mass function, so all the probability sigma, the probability k from 1 to infinite, all the probabilities accumulate to 1, and it's equals to b times the derivative of the p to the power of k, sigma k from 1 to infinite. And we want to compute the this accumulate function, so we could put it into the derivative, and it is equals to 1 times p times 1 minus p to the power of k over the 1 minus p, and limited k to the infinite. So when k is to the infinite and this function, this is 0, so we could compute it as the derivative p of p over the 1 minus p, and the derivative of this is 1 minus p, the bracket to the power of 2, and the numerator is 1, so it's equals to 1. So the b is equals to 1 times b, the bracket to the power of 2. So the probability function is equals to the 1 times b, the bracket to the power of 2, and times k times p, k minus 1. So for the question b, we want to find the expected value of x, and the expected value of x is equals to the sigma k from 1 to infinite, the k times the probability of x equals to k. So we want to compute this is equals to the 1 times 1 minus p to the power of 2 times the sigma k from 1 to infinite times k times p, k to the power of k minus 1. So we could use the derivative, also use the above method to put this as a derivative of p sigma sigma k from 1 to infinite, the k times the p to the power of k. And for this, it's hard to compute, so we could put 1p at the before it, so we could put it as transform it as the p times k to the times the sigma k from 1 to infinite, the k times p, k minus 1. So this is equals to the derivative of p to the sigma k from 1 to infinite p to the power of k. So the ex is equals to the 1 minus p to the bracket to the power of 2 times the derivative of p, the bracket p times the derivative of p, and the sigma k from 1 to infinite the p to the power of k, and it is these functions. So we could use the above value to find it is equals to it is equals to 1 times p the bracket 2 to the power of 2, the numerator is 1, and we could also compute this derivative, and it's equals to it's equals to the the 1 minus p to the power of 4, the p derivative of p times 1 minus 2 minus p to the power of 2 minus the derivative of this one and times the p. So we could put all this as is equals to 1 times p over 1 minus p to the power of 3, and we could times this and to this, so the EX is equals to the 1 plus p over the 1 minus p. And for the question C, we want to compute the EX to the power of 2, so we could also use the above function, above value. The EX to the power of 2 is equal to sigma k from 1 to infinite the k to the power of 2 times the px is equal to k. So it's equals to 1 times p is b, and times the sigma k from 1 to infinite the k to the power of 2 times k times p to the power of k minus 1, and we could also do this as the derivative of p sigma k from 1 to infinite k to the power of 2 and times the p to the power of k, and we also could let 1p at the former, and it is equals to derivative of p times the derivative of p sigma k to 1 from 1 to infinite the k times pk. And we could also put 1p, and it's equals to derivative of p times derivative of p times p times derivative of p sigma k from 1 to infinite the p to the power of k. And we could transform this function to this function. So the expected value of x to the power of 2 is equals to 1 times p to the bracket to the power of 2 times the derivative of p, this function, and the sigma of p to the power of k, and we could use the above value in the question A and question B. It is equals to 1 over the 1 times p to the bracket to the power of 2, and this is equal to 1 plus p to the 1 minus p to the bracket to the power of 3, and to times p, and to compute this derivative, and it's equals to 1 times the denominator is 1 times p to the power of 6, and to do this derivative is p is 1 times 2 times p, 1 plus 2 times p, and times the 1 minus p, the 3 power, and the minus the derivative of this times this is 3 times 1 minus p to the 2, and times the minus 1 times the p times 1 plus p, and we could eliminate this one, and this one is 4, and it's equals to the p times 1 minus 2p to the power of 2, and plus the 3p to the power of 2, and plus the 3p over the 1 times the 1 minus p to the power of 4, and there also is the b is we could eliminate to 2, so the the expected value of x to the power of 2 is equals to 1. The denominator is 1 minus p to bracket to the power of 2, and this is equals to 1 times 4 times p, 1 plus 4 times p plus the p to the power of 2. So this is the expected value of x to the power of 2, and we could, at the question D, we want to compute the c minus the b, so it's minus the b to the power of 2, so we could compute these two as this function and minus this function to the power of 2 is equals to this function to the power of 2. So it's equals to 1 times the minus p to the power of 2, and the numerator is the 2 times p. So it's the question D's value. And for question E, we want to for question E, the p is equals to 1 over the 3, so the b is equals to 1 times 1 minus p to the power of 2 is equals to 4 over 9, and the probability of x equals to k is b times k times p to the power of k minus 1 is equals to this 4 over 9 times k times the 1 times 1 over 3 to the power of k minus 1. And we want to compute this function and the probability of this. The probability of this, we could use the conditional function, and it's equals to the probability of x equals to k, and intersect the 2 x bigger or equal than 2 and smaller equal to 5 over the probability of x equals to k, the sigma k from 2 to 5 So we could compute this, use this function, and is equals to about 0.5377, and this is not exact value, is a function. The x from 2 to 5, there we could use the px is equals to probability of x equals to k, but otherwise it is probability is 0. So we could do this probability as the 0.5377, the numerator of 1, and times the probability of x equals to k is this function. And for this condition, the k is from 2 to 5, and for otherwise the probability is 0.